Here is a representation of electric field lines. You can see that these fields are caused by a positive charge A negative charge C, and a positive charge B. You can also see, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 field lines, 14 field lines coming out of A, and only 5 coming out of B, that A is going to be a bigger charge by a ratio of 14 to 5. Now C has got the same number of field lines as A, so it's going to be the same size charge but negative. Now, if I were to ask you, if I take a little positive test charge and put it at 1 and 2 and 3, what direction would the field point? A lot of people make this a hard problem by throwing away the gift. Those field lines are a gift. It took me forever on the computer to generate them. And people use them to just find out how big a charge A, B, and C are, and then they go back to their silly equation, and they make it very difficult. All they have to do is say, well, the push, it's a positive test charge, the push is in the same direction as the E field, and that's tangent to the field lines. And if I were to ask you to compare the size of those pushes at 1 and 2, again, some people, not you, but some people throw away the gift, throw away the field lines, and they say, oh, well, 1 is really, really close to 2 big charges, and 2, it's close to a big charge, but also a little charge, but maybe C is negative, so maybe that comes in. They get all confused. All they have to do is say, field lines close together, stinky. Field lines far apart, not stinky. And so the force would be bigger at 1. If I compare 2 and 3, they're closer together at 3, and so 2 would be the weakest. You see how you use those?
At point 3, since it's in between the lines, how do you know what you direct?
If it's between the lines, you look at a tangent to this line and a tangent to that line, and you take an average between those two directions. Well, they call it interpolation, but it's really just averaging. Okay? Folks, we got 2 minutes. There's one big question here. If that test charge that I was placing at 1, 2, and 3 were suddenly double the size of the charge, how does that affect the force, and how does that affect the field? Tell your neighbor. How does it affect the force? How does it affect the field? Okay. Here's the answer. The field is caused by A, B, and C. It is independent of the test charge. It's made by the sources. And so the E stays the same. But if the E stays the same, and I double the test charge, I double the force. So the force would double, and the field stays the same. Okay, have a great weekend.